Welcome to Hamilton Math. In this video, I'm going to cover 23 practice questions that covers the entire grade 10 math course in only 1 hour. The secondary school curriculum says that it should take a minimum of 110 hours to cover a course like this. We're going to go over the whole thing in only an hour. So whether it's review for the exam or any unit test, or an introduction to see what the course covers, I hope you'll find this valuable and thorough as we look at all topics, including linear systems, triangle and circle properties, factoring, quadratics, and trigonometry. You can scan the QR code for the worksheet with all the questions from this video or see the link below in the description. Let's get going with Linear Systems Unit 1, where we're going to cover graphing, elimination, and substitution.
So let's look at linear systems. The first question that we're going to look at says this: solve the following system of linear equations graphically and using the substitution method. Now you'll notice that we have two equations there. And you'll notice that the first is in the form y equals mx plus b, where that slope, m, is -3/2. The y-intercept is 5. To graph that, we start with the y-intercept, so we go to 0, 5, and then we go down 3 and to the right 2, down because it's -3. We go that and we continue that pattern, draw the line through those points, and we label that with the equation. You'll notice the second equation is not in the form y equals mx plus b, so what we're going to do is we're going to rearrange that equation so that we can actually go ahead and write it in that form. If I add 1/2 x to both sides, it cancels off the right side, and I'm left with y equals 1/2 x minus 3. And so we go ahead again, recognizing that the 1/2 is the slope, the -3 is the y-intercept, and so we start with the point 0, -3. We plot that point first, and then from there, we go up 1 over 2, up 1 over 2. We're always going over to the right. And so we plot a number of points, draw the line between those points, and label it with the equation. And we can see there that the solution is going to be at 4, -1. So we've done it graphically. Let's talk about the substitution method. So we're labeling the equations 1 and 2. And we're going to take that first equation because y is already isolated, and we're going to substitute everything that y is into equation number 2. So where we had the y, we're going to put -3/2x plus 5, and then we're going to continue equation 2 with -1/2 x equals -3. So we've substituted equation 1 into equation 2. And now what we want to do is we want to get the like terms together. So we want the 5 and the -3 together. We're going to get that together by subtracting 5 from both sides. It's going to cancel off the left side. And then we want the x terms together. -3/2 minus 1/2 is -4/2. And then -4/2 is just -2. So we get -2x equals -8. And we divide by the coefficient, which is -2. That cancels out, giving us x equals 4. Now we're not done yet because we now need to substitute that x equals 4 into one of the two equations. It's easier to sub it into one because y is already isolated. So I'm going to write y equals -3/2 times 4 plus 5. And now I'm going to just go -3 times 4, which is -12/2, plus 5, that's -6. -6 plus 5 is -1. So our solution for this is the x term first, followed by the y, 4, -1. And we say, therefore, the solution to the system of linear equations is that. You'll notice that's the same point we have on the graph as well, 4, -1. That's exactly what we did graphically. So both of them produce the same answer, which we want. Now we look at the elimination situation. It says find the point of intersection using the elimination method. We have two equations, and you'll notice that none of the coefficients are the same. We want one of the coefficients to cancel when we either add or subtract the two equations. So what we're going to do is we're going to multiply that second equation by 2 in order to have the same coefficient in front of the b term. So that's going to give me 16a minus 4b equals 14. I'm going to bring the first equation over, keep it the same. And so now what you can see is I have a 4 in front of the b, and then in the second equation I have a -4 in front of the b. So because of that, I'm going to add the two equations, 10a plus 16a, the 4b plus -4b, and the -1 plus 14. And so what I get when I add all those together, I get 26a equals 13. And so I divide by the coefficient in front of the a term, that's 26, and I get a equals 1/2. 13 divided by 26 is exactly a half. So now what I need to do is I go back to the substitution method for this piece of it, and I just substitute a equals a half back into one of the two equations. I'm going to choose equation 1. And so I'm going to get 10a, a is a half, so I'm going to sub that in, plus 4b equals -1. 10 times a half is 5. 5 plus 4b equals -1. I want to bring the 5 to the other side to get the b by itself. So I get 4b equals -6. and I divide by the coefficient in front of the b term to get negative 6 over 4, which simplifies to negative 3 over 2. So that's my solution to that system of linear equations. And if I was to graph this with the point of intersection on a graph where we have a as the x-axis and b as the y-axis. So therefore, the POI is 1/2 negative 3 over 2. Now it then says to check your answer algebraically. And so what we're going to do is we're going to start by looking at equation 1. And we're going to go, the left side is 10a plus 4b. We keep the left and right side separate. And we then go and we substitute the a value and b value into a and b. So 10 times 1/2 plus 4 times negative 3 over 2. We go ahead and we multiply the coefficients. So 10 times 1 is 10 over 2. And then 4 times negative 3 gives me negative 12, which is over 2. And that gives me 5 plus negative 6. And then 5 plus negative 6 is negative 1. And so we can say, therefore, the left side is equal to the right side. So we know it works for that first equation. But we haven't checked the second equation yet. So let's check that one as well to see if it works for that as well. So what we're going to do is we're going to, again, separate the left side and right side out. And we're going to substitute a and b in for the variables. So in the place of a, we have 1/2. And in place of b, we have negative 3 over 2. Doing the same thing as we did before, 8 times 1/2 gives me 4. Negative 2 times a negative times a negative gives me a positive, and so it ends up being 3. And so 4 plus 3 is 7. The left side is equal to the right side, and we can have confidence that we got that answer correct. It is, in fact, a point of intersection of 1/2 and negative 3 over 2. Number 3 says this: the admission fee for a virtual rock, paper, scissors competition is $1.50 for youth and $4 for adults. This past year, 2,200 people entered the competition. The money collected from the competition was $5,050. How many youth and how many adults entered the competition? First thing we need to do is we need to actually define variables here. And so we're going to let A be the number of adults who participated. And so if A is the number of adults who participated, then Y would be the number of youth who participated. And so the reason that we always define it as a number who participated in is because it allows us to find what it's asking in the question. It's all about defining what was asked in the question. The question is there at the end. And so we have $1.50 for youth and we have $4 for adults. 2,200 people competed and we raised $5,050. So we're going to start with the most obvious equation perhaps, and that is the fact that if we had 2,200 people, if we add the number of adults plus the number of youth, it's 2,200. But then we also have the total amount of money that was brought in. And so that looks at $1.50 for youth, so 1.5 times Y, and then $4 for adults, so 4 times A, and they brought in $5,050. And so I've written that just so that the A's are together and the Y's are together because I'm going to use the elimination method here, just like I did in the last example. So I multiply the first equation by 4. I get 4A plus 4Y, and then the A's are going to cancel when I go ahead and I subtract the one equation from the other. So remember, I had to multiply that entire equation by 4. So I subtract the two equations. 4A minus 4A gives me 0A. Now we go 4Y minus positive 1.50Y. We also make sure we 8,800 minus 5,050. Don't forget to subtract all the terms that are below it here. So we get 2.50Y, and 8,800 minus 5,050 gives me 2,950. So 250Y equals $2,950. I divide by 2.5. Whatever you do to one side, you have to do to the other. That's going to cancel out the coefficient in front of the Y. And Y equals 1,500, which means that we had 1,500 youth attend. Now, you could probably just think if we have 2,200 and 1,500 youth attend, then that means 700 adults. But if you want to go back to the algebra of it, you could do that as well. And the easier equation to sub that into to solve for the A would be equation 1. And so that's why I've substituted that into equation 1. The number of adults plus 1,500 equals 2,200. If we subtract 1,500 from both sides, we get the number of adults equals 700. Therefore, 700 adults and 1,500 youth attended.
Unit 2 is all about triangle and circle properties, analytic geometry. We're going to look at things like midpoint, slope, distance, and chords, and we're going to determine how to find centroids, orthocenters, circumcenters, and right bisectors. And you can see some of the equations there that we're going to use in this unit.
The first question says, joining these three vertices together produces a triangle. We've got A, B, and C, and we're to draw the triangle. So what I'm doing is I'm just plotting each of those points. A is 0, 6, B is 6, 3, C is -3, -1. And so making sure we're graphing the X, the horizontal, and the second coordinate is the Y, the vertical value. So then we plot the 3 points and join them together to form a triangle. and you can see that triangle ABC forming as shown. Now part B said find the slope of the median from vertex C. So the median from vertex C is a line that goes from vertex C and intersects the midpoint of the opposite side. So it's intersecting the midpoint of side AB. So you can see here what we're going to have to do is we're going to have to first find the slope. To find the slope, we're going to have to first find the midpoint of AB. And so in order to do that, it's just the average of the x values and the average of the y values. So it's x1 plus x2 divided by 2, y1 plus y2 divided by 2. And so the x value of A was 0, the x value of B was 6. Do the same thing with the y values. And then 0 plus 6 divided by 2 gives me 3. 6 plus 3 is 9 divided by 2 gives me 4.5. So the midpoint is 3, 4.5. So what we're going to do now is we're going to label that as point M. And we're going to note that now we're finding the slope of those two, or between those 2 points. So from C up to M there on the graph. So the slope of CM, the slope is always the change in the y values divided by the change in the x values. So y2 minus y1 over x2 minus x1. And so the second value is the m value. The y value of the m value is 4.5. The y value of the c value was -1. So 4.5 minus -1. Do the same thing with the x values. 4.5 plus 1, because if you subtract a negative, it makes you add. And then 3 plus 3, we get 5.5 over 6. Now what we can do is we can make that into a fraction that doesn't have a decimal in it. We never want a decimal in a fraction. And so we can say the slope of the median from vertex C is 11 over 12. Which if you look at that, the slope of that line looks to be about 1. So that's pretty good. Part C now says find the length of the median from vertex C. So we need to remember first off that the point C was -3, -1. And if it's the median, the midpoint of side AB was 3, 4.5. And so we want to find the length of the median. So that's x1 and y1 and x2 and y2. Just if that's helpful, you can draw that by the points all the time. So it's really easy to sub into the equations. Now the distance formula, in this case, we're doing the distance from C to M, is x2 minus x1 squared plus y2 minus y1 squared. And if you want to dig in more into this, it's really kind of the rearranged Pythagorean theorem is what it is in a sense. So it's a change in x values squared plus a change in y values squared. So the x2 is 3, x1 is -3, so 3 minus -3. And with the y values, we get 4.5 minus -1. In other words, you're going 3 plus 3 squared, so it's going to give you 6 squared. And then again, 4.5 plus 1 squared, so it's going to give you 5.5 squared. Then we go ahead and we take the 6 and we square it to get 36. Take the 5.5 and we square it to get 30.25. We add those together under the square root, 66.25, and that's approximately equal to 8.14. So our concluding statement would then be the length of the median from vertex C is 8.14 units. We're not told what units, so we'll just say units. Now, if we go back to the graph, we can see that that looks to be about a length of 8 from C to M. So that's just a way that we can kind of check to make sure we're on the right track if we didn't make a really bad mistake along the way by looking back at the graph at the end. So there you go. That's a quick way to do those two things. Now we have the property of a centroid. Determine the centroid given the following 3 points. Now, we have the points A, B, and C. We're going to go ahead and plot those on the graph first here. So A is 5, 8, B is -7, 3, and C is -1, 4. If you don't remember what a centroid is, it's the point where this triangle will balance if you put a pencil in the middle. So it's the balance point of the weight of a triangle. It's also the average of all the points. And so that's what we're going to do here to calculate the centroid. Is we're just going to use the average of all 3 points because the average is where it's going to balance to be having the same weight from all the vertices. So it's going to be somewhere around where I've graphed there on the graph. And so the centroid is equal to the average of the x values. So x1 plus x2 plus x3 all over 3 because we've got 3 values. And we've got y1 plus y2 plus y3 over 3. And so we've got 3 values there. So we're dividing it by 3. And we're just going to sub those in. And so I'm starting with the A, then I'm using the B, then I'm using the C. So 5 plus -7 plus -1. And then we're doing the same thing with the y values of A, B, and C, dividing those by 3 as well. We add them all together in the numerator, then we divide them by 3. So we get -3 over 3, and we get 15 over 3. And this works out really nicely in this case. We get -1 and 5. And so that is the centroid of that triangle. We look back to make sure we're on the right track. And it seems that the point -1, 5 is right about where I thought the centroid should be. And so that would therefore be correct. So the centroid therefore is -1, 5. And so here's the picture of that. There's just how the centroid is the balance point. And so if you put a pencil right at that point, the whole triangle would balance on it. And then we had two other things we talked about in this as well. But first, let's just remind ourselves that the centroid is formed by the medians where they intersect. But then if we look at the orthocenter and circumcenter, if we talk about the orthocenter, that's where the altitudes intersect. So an altitude is a line that passes through a vertex and then goes 90 degrees to the opposite side of the triangle. So where those intersect is called the orthocenter. Last but not least is where the right bisectors intersect, or the perpendicular bisectors. Some people might call it that. It just means a 90-degree bisector. So 90-degree angle, and it bisects the side. It cuts it in half. And so where those join together, that is called the circumcenter. And the reason there's a circle there is because if you drew a circle through those three vertices, it's where the center of the circle would be, since the circle center. There you go. Those are the three terms you need to remember about triangles from grade 10 math. All right, moving on to the last thing is determine the equation of a circle centered at the origin of radius 3. So x2 plus y2 equals r squared. I shouldn't say 2, I should say squared. That would be the more technical, better way to say that. And so the r is the radius. And so here we've got a radius of 3, so we just put 3 squared into that, and we get x squared plus y squared equals 9. And so that's the equation of a circle centered at the origin of radius 3. That's all there is to it. It's really that simple. And so I said this is technically another question, but it's the same idea of circles. So that's why we're focusing on now here at the end is circles. And so this question says, does the point 3, 5 lie inside, on, or outside of the circle of radius 6 centered at the origin? So you can see from the diagram, it looks like it's inside, but it's pretty close, so it's hard to tell. So we always want to calculate this using algebra. So I'm going to substitute in 3 and 5 for the x and y values at that point, and I'm going to find that that gives me 34. And so what that means is that a circle that went through 3 and 5 would have an r squared value of 34. Well, that means that the radius would be the square root of 34, which means approximately a radius of 5.83, which is definitely smaller than a radius of 6. Okay, so then if we know that's a smaller radius, therefore the point 3,5 or 5,3, it doesn't matter what, because they're both going to work out the same, but it should be the point 3,5 is inside the circle. And so there you go. 0.35 or 5,3, doesn't matter the order of x and y, they're still going to be inside the circle because it still works out to be the same. So the last thing about circles is this. What is unique about any chord and its right bisector on a circle? Well, what is a right bisector? A right bisector, well, first off, a chord is a line between 2 points on a circle. And then a right bisector is a 90-degree line that bisects. It cuts the chord in half. If you draw that, it goes right through the center of the circle. Here's another chord that we're drawing. And so if we draw that chord there, and we also draw the right bisector to that, it's going to also go through the center of the circle, which maybe is just a little bit further down than I originally drew there. And that is also a right bisector that cuts through the center of the circle. I could draw it anywhere on the circle, way down here as well. And if I draw the right bisector there, that again is going to go through the center of the circle. So that's the unique thing about any chord and its right bisector on a circle, is that they will always go through the center of the circle. Which brings us to the end of analytic geometry. And we've looked at circles and we've looked at triangles, and that's all that we need to know about analytic geometry from grade 10.
Unit 3 is all about factoring. We're going to start by expanding, then we're going to learn how to common factor, then factor trinomials, perfect squares, and differences of squares, and finally solve a quadratic equation using factoring.
So the first thing we want to do is we want to expand. That's the opposite as factoring. And so the way we expand something that is a binomial times a binomial, 2 terms times 2 terms, is we do FOIL, first, outside, inside, last. So what we do is we take the x and we multiply it by 2x, and that gives us 2x squared. That's the first 2 terms. And then what we do is after we get the 2x squared, we go to the next, the outside terms. It's x times -7, and that gives us minus 7x. And then we go the inside, that's 5 times 2x, which gives us 10x. And then the last, 5 times -7, which gives us -35. Now, the middle 2 terms are like terms. The minus 7x and the positive 10x can be combined, so we get 2x squared plus 3x minus 35. Now I want to show you that FOIL isn't the only way to do this. The whole idea is that we're multiplying every term in the first set of brackets by every term in the second set of brackets. So one way to do that is I could take the x in the first set of brackets and multiply it by the 2x minus 7. And I could take the 5 in the first set of brackets and also multiply it by the second brackets, 2x minus 7. Now we're going to use the distributive property to multiply x times 2x and x times negative 7. That gives us 2x squared minus 7x. And then the distributive property again, 5 times 2x gives us 10x, and 5 times negative 7 gives me negative 35. Again, collecting the like terms in the middle, we get 2x squared plus 3x minus 35, the same answer that we got on the left. So whether you use FOIL or you just go ahead and multiply every term in the first set of brackets by every term in the second set of brackets, you get the same result. Now what we have there is the expanded form. And so the factored form is what we started with. And so we can go back and forth between those two forms. We've just expanded it this time, but normally what we want to do is we want to factor it because it allows us to be able to graph quadratics in the next unit. So let's go ahead and look at factoring. So the first factoring question says this. It's 2a, and it says 4x squared y cubed minus 16x cubed y squared minus 24y. And so we always want to start by common factoring if possible. So here the only thing that's common as far as the number that's a common multiple is there's a 4. The x's, there's no x in the last term, and the y, there's only one y in the last term. So that's why we can only common factor at a 4 and a y. So then we divide every term by 4y, and we're left with x squared minus 4x cubed y minus 6. And now that is unfactorable, and so we've gone as far as we can go, and technically we factored it, but we can't go any further than that. So now to the second situation. The second situation is one that what we did previously up above, we would have just expanded it out. But we don't want to expand here. We want to actually factor it. We want to go the opposite direction. So to go the opposite direction, rather than going 2x times x and 2x times minus 7, we want to think, what would it do if I went back a step in the expansion? Well, that would be the 2x plus 3, and then you have that x minus 7 that's a common factor to both 2x and to 3, and so you write it out like so. So there you go, that's the second example. Now to the third example, 2x squared plus 10x plus 8. Now we see the 2, and initially that seems to be making things more difficult, but we can common factor first. We always want to do that first. So that gives me x squared plus 5x plus 4. And now it's a simple trinomial. I need to find two numbers that add to the middle term, 5, and multiply to the last term, which is 4. And so those two numbers are 1 and 4. And the nice thing about a simple trinomial where we have a 1 in front of the x squared term is that we can just go ahead and write the final answer out. We don't need to do any decomposition or anything because that is the answer. It always will be. So we still have that factor of 2 up front, but we have x plus 1 times x plus 4. And you can expand that back out to check to see if you got it right. D now is one where we can't common factor out that 3. So what we have to do is we have to find two numbers here that add to the middle term, minus 10. And in this case, because the 1 is not in front of the x squared, we need to go 3 times negative 8. We need to multiply the a times the c terms together. So we want to find factors of negative 24. And so 1 and 24, but we look at it because it has to add to a negative, we want the bigger term to be negative. And that doesn't work, but the 2 and negative 12 does. So 3x squared plus 2x minus 12x minus 8. Here's where I have to use factor by decomposition. So we're going to take the first two terms and common factor out of those. So an x out of both of those gives me x times 3x plus 2. And now I want to take a negative 4 out of the next two terms, and that's also going to give me a 3x plus 2. The key there is if those are not the same, you haven't taken out the right value or haven't factored things properly. They have to be the same, and the signs also has to be the same. So just like we did in B now, we're going to take that last step. We have that x minus 4, and the common factor is 3x plus 2. So that's our final answer as shown. And just note that negative had to be factored out in order to get it to work out with the right signs, as I mentioned. All right, let's look at the next example now. 16x squared minus 121y squared. This is a difference of squares. The idea here is that we have two squares, and there's a difference between them, the minus between them. Basically, anytime you see two terms, it's probably going to be a difference of squares. It might not be, but it usually will be. So the idea here is if we take the square of the whole first term, we get 4x, and that's 4x all squared, because the 4 squared would give us back the 16. And then we have 11 squared would give us back the 121. So it's maybe easier to see there. So now we take the 4x and the 11y, we write it out as adding them together and subtracting them from one another. And so the general form of this, just if you're not quite following with this, is that if we have an a squared minus b squared, it's equal to a plus b times a minus b. And so in this case, the a was 4x, the b was 11y, so we wrote 4x plus 11y and 4x minus 11y. So on the right, we have a situation that is a perfect square. Now, we might not see that initially, but what we're looking at is the first and last terms. So we can see the first term, we can take the square root of that, and the last term, we can take the square root of that. If we take the square root of the first term, it's 3x. If we take the square root of the last term, it's 2y. And so then we look at the middle term. We say, is the middle term twice 3x times the 2y? And if it is, which it is in fact here, 2 times 3 times 2 gives me 12, and x times y gives me xy, then it is a perfect square. And so what we're going to do here is we're going to write it as 3x, and then plus or minus 2y. Well, it's a minus if the minus is in front of the second term. And then we write that all squared. So the general form in this situation, if we wanted to see that play out here, would be something that is in the case of a squared minus 2ab plus b squared is equal to a minus b all squared. Remember, the sign of the second term is the sign that's going to be between the a and b. So if I have a plus 2ab plus b squared, then that's going to be a plus b all squared. And so those are your two forms that you're going to have for a perfect square. So we've got tricky trinomials, we've got simple trinomials, we've got common factoring, differences of squares, and now perfect squares as well. So let's see what we would do if we were asked to solve the following quadratic equation. We have x minus 10 times 2x plus 3 equals 54. To solve, we need to have it equal to 0. And so in order for us to get this equal to 0, we actually have to expand this out and get everything on the left side of the equation. So we want to subtract 54 from both sides of the equation. So what's going to happen here is I'm going to go ahead and I'm going to use my FOIL again. You can expand that however you want, but the whole idea is that every term on the left has to be multiplied by every term in the other set of brackets. And so we get x times 2x gives me 2x squared, x times 3 gives me 3x, negative 10 times 2x is minus 20x, and negative 10 times 3 is negative 30. So there we have equaling 54. Now to get that 54 to the other side, we're going to subtract 54 from both sides. Whatever you do to one side, you have to do the other. And we're also going to combine those like terms on the left. So we get 2x squared minus 17x minus 84 equals 0. So now it's in a form where we can solve it because it's equal to 0. But now we have to actually go ahead and factor again. Now we can't common factor here because we can't take a 2 out of 17. So we're looking for two terms that adds to the middle term of negative 17, multiplies to 2 times negative 84, which is negative 168. This is going to take a little bit of work. I'm going to do it pretty quickly on the screen, but in reality, it's something that takes a little bit more time as you actually do it. So first thing we're going to do is we're going to look for factors of 168. 1 and negative 168 is nowhere near negative 17. We're just going to keep working through the factors that we can find, doing this on our calculator, dividing by 2, dividing by 3, dividing by 4, etc., and then adding those two factors together. And you can see here that we're getting closer to negative 17, but we're not there yet. 4 and negative 42 gives me negative 38. When we get to 6, 5 is not possible. We get to 6 and negative 28 gives me negative 22. We're very close now. And then 7 and negative 24 gives me negative 17. Awesome. So that means that that negative 17x is going to be decomposed into 7x and negative 24x. So you can see that I'm breaking that down into those two terms there. So just as shown, and that's the same thing as the line above it. So now what I want to do is factor by decomposition. So I'm going to take the first two terms and x out of those two terms. And now what I want to do is I want to be left with an 2x plus 7 in the brackets in the second case. So I'm going to take out a negative 12 to get that 2x plus 7. And 84 divided by negative 84 divided by negative 12 is in fact positive 7. So that's going to be equal to 0. And so now just the last step, we go x minus 12 times 2x plus 7. I said that's the last step, but that's the last step in factoring. That's not the last step in this question. It's asking us to solve it. So what we actually have to do is we have to go x minus 12 is equal to 0, or the 2x plus 7 is equal to 0. So we add 12 to both sides here. We get x equals 12. On the right side, we have to subtract 7 from both sides. We always do reverse order of operations, so we have to subtract or add before we multiply or divide. And then we divide by the 2, and negative 7 divided by 2 gives us x equals negative 7 over 2, or negative 3.5. So there you go. those are your two solutions for solving that quadratic equation. So we've gone over a lot of different things, noticing that we had to expand it initially, then we had to factor it, and then we finally had to solve it.
In Unit 4, we're going to take the concepts we learned in Unit 3 and apply it to quadratics by completing the square, graphing parabolas, doing transformations of graphs, and getting the equation from a graph. We're going to learn 3 forms of a parabola and learn how to graph from each one of these 3 forms.
So the quadratics unit is all about polynomials where the largest power is x squared. So the first question says, what are the 3 forms of a parabola and what does each form tell you? How do you go between the 3 forms? Well, one form is the standard form, and that is y equals ax squared plus bx plus c. That's the first form, and that has no brackets. It's fully expanded and simplified like shown. Another form is factored form, and the factored form is, as you guessed it, factored. So we have 2 sets of brackets, y equals ax minus r, x minus s. The final form is the vertex form, and the vertex form is in the form y equals a times x minus h all squared plus k. And that h and k is the vertex, and that's why it's called the vertex form. And so now what does each form tell you? Well, the standard form tells you, the c value tells you that it's the y-intercept. And so you just look at that last term without the x in it, that's the y-intercept. For the factored form, the r and the s values are the zeros. Those are the x-intercepts. So the zeros are x-intercepts, those mean the same thing. For the vertex form, what that tells you is, as I already mentioned, the h and k is the vertex. And so those are the 3 key things, but all 3 forms tell you one other thing. They all have the same a value. A is the vertical stretch or compression factor. And so that is the same in all 3 forms of a parabola or of a quadratic. And so if the absolute value of a is bigger than 1, in other words, if you're 1 or bigger, then it's a stretch. If it's less than 1, if it's a fraction that's smaller than 1, then it's a vertical compression. And so that's the key thing to keep in mind when we come later to graphing in a moment. So that's really the main thing. So now how do you go between those forms? Well, to get from factored form to standard form, you just expand. We can FOIL that out, first, outside, inside, last. To go from standard form to factored form, we need to be able to factor, and you can see my last video for that. To go from standard form to vertex form, what you need to be able to do is you need to be able to complete the square. We're going to do that later in this video. If you're going backwards now from vertex form to standard form, we're going to expand it just like we would from factored form, recognizing that the x minus h squared is the same binomial times itself. So you can use FOIL if you need to there. Now, there's no way to get directly from vertex form to factored form or from factored form to vertex form, so you have to go through the standard form to get from those 2 side forms to the other. So the second question is this: determine the maximum or minimum of the following quadratic relation by completing the square. So here is where we cover how to do that. So we have y equals 2x squared minus 12x plus 14. And so the key to remember is that to get a perfect square, it's in this form. So a squared plus or minus 2ab plus b squared is equal to a plus or minus b all squared. In the last unit, I factored those. But here, we're going to factor it once we form a perfect square. So in order to do that, we need a common factor of the 2 out of the first 2 terms. The 2 divided by 2 gives you just 1, and the 12 divided by 2 gives you 6. So x squared minus 6x plus 14. We take that 6, the term that's attached to the x, we divide it by 2 and we square it. Sometimes that's called the magic number. And then we add that magic number and we subtract it inside the brackets. From there, we go ahead and we multiply the 2 times the negative 9. And we want to now bring that outside of the bracket. So 2 times negative 9 is negative 18. And then we still have the plus 14 at the end. And what we have now is a perfect square inside the brackets. What you'll notice if you look at the form a squared plus 2ab plus b squared, we have an x squared minus 2 times x times 3 plus 3 squared. And so in this case, it's the minus part of the perfect square. So that means the term, the sign of between the 2 terms in the binomial will be a negative. So it means x minus 3 all squared. And so we get 2 times x minus 3 all squared minus 4. And so from there, we can determine the maximum or the minimum with that. And it's worth noting as well that the 9 and the x squared, whenever you do this, it's always going to give you a perfect square. So you just take the square root of both of those 2 terms and write them in this line below that. So now what we can do is we can recognize that's in the form of y equals ax minus h all squared plus k. And so the vertex being h and k means that the vertex here is positive 3, careful with that, and negative 4. So there you go. that's the vertex. But we still haven't been able to determine if it's a maximum or minimum. Because the A value is 2, that means it opens up. And so that means that it has to be a minimum at that vertex value. It's a minimum of that vertex value or at y equals -4. So there you go. That's that example. Now example 3. Transform y equals x squared to y equals -2x plus 3 all squared plus 4 and describe the transformation in words. Now you'll see what I'm doing there is I'm starting by just graphing the graph of y equals x squared, which we should all be able to do by now when we've done quadratics already. We know that we just substitute the x values in of 1, 2, 3, and we get the squares of those, which is 1, 4, and 9, and the same on the other side because we have symmetry about the x-axis. And now we look at this second equation and we recognize that that's in that vertex form. And so we want to start listing some of the transformations that those mean. What a lot of people get mixed up on is they get mixed up on the h value. So what I'm doing here, because it's x plus 3, I'm writing it in the form of x minus h. And so now we can clearly see that subtracting a negative is the same thing as adding. And so what that means is the h value is actually -3. So a is -2, that's obvious, it's right in the beginning. As I noted already, that h is -3. And then the k value is +4. And so let's describe what each of those are doing to the transformations. So the a value being -2 is going to be a vertical stretch by a factor of 2. Vertical stretch by a factor of 2. The negative part of that means that it's going to flip it over the x-axis. It's always flipping vertically, so it's flipping over the x-axis. Another way to say that is reflecting over the x-axis. And so what I'm going to do is I'm going to take all those 7 key points that I've drawn on the blue parabola, and I'm going to take each of those, I'm going to vertically stretch each by a factor of 2, so I'm going to double all the y values, keeping the x values the same, and then I'm going to flip them down over the x-axis. So instead of 2 and 8, it's going to become -2 and -8. And so you can see there, I've plotted those 2 points that would be at -2, and now the 2 points that are at -8, and then the points that are at 9, the y values that were at +9, would become -18. They're not going to fit on this graph, so we're going to draw the curve through those, and I only have 5 key points that are left. That's just with the a value applied, so it's y equals -2x squared. Now, as I noted that h is -3, that means that there's a shift of 3 units left. The reason it's to the left is because it's a negative. Negative goes to the left, positive goes to the right. Remember, that's not how it's necessarily shown in the equation, right? As I already went over earlier. So what we're going to do is we're going to take the 5 key points, we're going to shift them all 3 units to the left, and just plot those points 3 over. And that is the graph now with both the a value and the h value applied. So we've got the -2, x plus 3 all squared, or x minus -3, if that's helpful. The last thing is the k value, and that shifts it 4 units up. Positive goes up, negative goes down. That's the key to remember there. So because it's positive, it's going up. So we're taking all those 5 key points on the black curve, and we're moving them 4 units up. And as soon as we plot those 4 points, it's going to be at 3, 4 is the vertex, or -3, 4 is the vertex. And then all the key points have the same shape as the black curve did. And we're then drawing our curve through those points. And that is our final transformed function. So the question said to transform it and describe the transformation in words. We've done both of those things. Oftentimes your teacher won't require you to do all of those transformations, but usually we like to see the a value and the h and k usually can be combined. That's usually fine to do that. So that's how you go ahead and graph that. Question 4 now says graph y equals 2x plus 3 times x minus 1 by finding the zeros in the vertex. So it's in factored form. In order to find the zeros, we need to let y be equal to 0. So we get 0 equals to the equation that we had up top, 2 times x plus 3 times x minus 1. And if we divide both sides by 2, that just cancels right out. 2 divided by 2 is 1. So we get 0 is equal to x plus 3 times x minus 1. So each of those factors, one of them has to be 0, or the other one has to be 0 in order for them to multiply to give you 0. So we solve for what each of those would be. Either x is equal to -3 or x is equal to +1. And those are our x-intercepts, or those are our zeros. So we can go to our graph and we can plot those 2 points on the graph. That's where the parabola is going to pass through the x-axis. Now we go for the vertex. And in order to find the vertex, there's a number of ways to do that, but the easiest way to do if it's in factored form is to use the zeros or use the R and S value, add them together, divide by 2. So that's what we've done here. We've used the two zeros, added them together, divide by 2, and we get -1. Now we sub that -1 back into the equation. And so when we do that, we're able to find the y value of the vertex. And we get y is equal to, here, 2 times +2 times -2. Be careful when you're adding or subtracting your integers. So we get y equals -8. So what that means is there's a vertex at -1 and -8. And just to check that, your vertex, your x value of the vertex, better be exactly between your x-intercepts because of the symmetry of a parabola. And in fact, it is here. So there's x equals -1. There's the point where y is -8. And we can draw our curve of best fit through those points. And that is the graph of y equals 2 times x plus 3 times x minus 1. So now the next question says, determine the equation of a graph on the right in vertex form, factored form, and standard form. We're going to do it in all three forms. And so there is the vertex form, general form of it. And what we're going to do is we're going to identify the vertex and one other point. You need to have the vertex and one other point. It doesn't matter what other point. I'm using the y-intercept because it's a really easy point to use, but you don't have to use it. But you do need the vertex and you need one other point, any other point, in order to use this form. And so the vertex is at 118. The point is that I'm using is 016. That's the y-intercept as I noted. And so I'm letting the point be the x and y values, and then the vertex values are h and k. So I'm going to substitute all these values into that general form of a vertex form. And when I do that, I'm going to get 16, because that's the y value. So 16 is equal to a. That's what I'm trying to solve. I don't know a. That's the whole trick here. I want to figure out what a is. X is 0, so I'm going to sub in 0. H is 1, so 0 minus 1 all squared. And k is 18. So now what I want to do is I want to rearrange the equation for a. So I'm going to go to 0 minus 1, and I'm going to simplify that. 0 minus 1 squared is -1 squared. And so now I'm going to use the reverse order of operations to rearrange. So I'm going to subtract first. So SAMDEB I'm using here, rather than VEDMIS, the reverse order of operations. And so now I've got -2 equals a times -1 squared. -1 squared is 1. And so now I can divide by 1, because it works out, there's nothing to divide by. So it's really nice this way. So a is -2. And so we get a final answer substituting the a value in and substituting the h and k values in, leaving the x and y as general variables in the equation. So we get y equals -2, x minus 1 all squared plus 18. So now that we've done the vertex form, let's move on to factored form. Remember, the factored form is y equals a times x minus r times x minus s. And so what we have to start by doing is identifying where the x-intercepts are. You can see here that they're at -2 and +4. So that means that r is -2 and s is 4. When we substitute those in, it's going to mean we subtract -2 and subtract 4 in the equation. Now we also need another point. I could use the vertex. I could use any other point where it's clearly going through. I think the easiest one to use is 016, the y-intercept, and so I'm going to use that here as well. So I'm going to substitute these r, s, and xy values into the equation. Again, I need to try to solve for a. Now we know what a is, so we could already write this equation, but let's assume we didn't know what the vertex form was, and we didn't solve for a earlier. And so if we didn't, we'd have to solve for a using this method. So we'd have to substitute y equals 16, x equals 0, r equals -2, and s equals 4, and then solve that for a. And it better be the same thing as we had in vertex form, because it is the same graph, right? And so let's see if it is. So we get a times 2 times -4, so that's -8a, and that's equal to 16. We divide by the coefficient in front of a, and we get a equals -2. The -8 divided by -8 gives us 1 times a. And so 16 divided by -8 is -2. So what that means is we can write that as y equals -2 times x plus 2, because it was subtracting a negative, and then x minus 4, just as we substitute those values in earlier. So now, if you're writing in standard form, that's something you can't solve directly. You have to first find it in vertex form or factored form, and then put it into standard form. So what I'm going to do for part C here for standard form is I'm going to FOIL this out. X times x is x squared. X times -4 is -4x. 2 times x is +2x. And the 2 times -4 is -8. And I'm going to get rid of the brackets by expanding and simplifying. I'm going to combine those middle terms, the negative 4x and the positive 2x. It gives me negative 2x. And then I'm going to use the distributive property to get the negative 2 times all the terms in the bracket. So I get negative 2x squared plus 4x plus 16. So we've been able to come up with this in all three forms. And note that the a value is negative 2 in all those forms. It's the same in all the forms.
Unit 5 is going to bring us back to triangles as we look at trigonometry. We're going to look at similar triangles, SOH CAH TOA for right triangles, and then the Sine Law and the Cosine Law, which are on the screen for non-right triangles. We're going to learn how to solve any triangle.
So the first question I'm going to look at with you is how can you show if triangles are similar? What properties are helpful? Now notice on the triangle ABC we know 3 side lengths as we do on triangle DEF. And so what we're going to do is we're going to do side, side, side similarity. We're going to look at the ratios of corresponding sides between those two triangles. So starting with side DE, we're going to compare that to side AC. And so those are both diagonal lengths on those two triangles, so it makes sense those would be the corresponding sides. So 26 divided by 13 gives me a ratio of 2. I'm going to do the same thing with side AB compared to side EF. So EF over AB, the bigger side over the smaller side, just so that we get a number bigger than 1 as our ratio. And so that's 10 over 5, that gives us 2. And I'm going to do the same thing yet again with sides DF and BC. And so DF is 24, BC is 12, and that again has a ratio of 2. And so because all those ratios are the same, that means those two triangles are similar. But we have to be careful with how we label this because the vertices need to be in the same order. So we did ABC. A corresponds with vertex E on the big triangle. B corresponds with vertex F on the big triangle, so that's the next letter. And then vertex C corresponds with vertex D. So we say triangle ABC is similar to triangle EFD by side, side, side. Now look at the next situation. We now have an angle and 2 sides. And so we have side, angle, side similarity that we're going to try to show in this next situation, which is different than side, 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 as you can see. And so what we're going to look at is we're going to look for, first off, the ratios of sides are the same. So we're going to start with DF, compare that to AB, 10 over 5, that's 2. And we need this other ratio to be the same as well. So EF, that's the other side we know on the big triangle, divided by AC is the big side, the longest side on the small triangle. That again gives us a ratio of 2. So this seems to be that these are going to be similar triangles, but we don't know unless we also check one of the angles, and we know that one of the angles is the same. And it's clear that they're both 90 degrees. Therefore, triangle ABC is similar to triangle. If you want, pause the video and see if you can label what it is, but it's F that corresponds with A, and then D corresponds with B, and then we end with E. And so that's triangle ABC is similar to triangle FDE by side, angle, side. Now the third situation is just angle, angle. If we know 2 angles in one triangle, we know they're the same in another triangle, then we know those 2 triangles are similar. This is the easiest one to check. And we can see just from the diagram that they both have 67-degree triangles and both have 90-degree angles. So triangle ABC is similar to triangle D, that corresponds with A, so the order matters. E corresponds with B, and then F. So this one is nicely in alphabetical order, while the other ones were not, and that's because of angle, angle. So those are the 3 ways. Now we're going to apply those to this situation. So it says find the length of DE in the drawing below. So it's worth noting first off that the 2 angles I've just shown there are going to be opposite and the same. And then we have these parallel lines as well. And so those parallel lines form some interesting patterns, one being the Z pattern. And so that forms, that means that ABC is the same angle as DEC. And then if we draw a Z the other way as well, it means that angle BAC is the same as angle CDE. And so all we have to do is show that 2 angles are the same. And so we're going to start by proving that similarity, which I did just talk you through, but let's see how we would write that down. If you were writing a test, this is what you would be expected to do. So you'd say angle BCA is equal to angle ECD. And that's by opposite angles. And so those are the first angles I labeled there. And then you could pick one of the other 2. And so angle ABC is equal to angle CED. You could have labeled that DEC. Doesn't matter, just provided the E is in the middle between those. And so those are called alternate angles. That's the Z pattern. And so we know that those 2 triangles are similar, which is now going to allow us to calculate things with those similar triangles. So we can say therefore triangle ABC is similar to triangle D, corresponds with A, angle E correspond with B, and C corresponded with C. So triangle DEC by angle angle. So now that we've proven that they're similar, we're going to solve the length of DE. And so in order to solve the length of DE, we're going to set up a ratio between values that we know versus the one value we don't know. We don't know what DE is, so I'm going to write that on the top because it's easier to find what I don't know when it's in the numerator. And I'm going to write that over the corresponding side on the small triangle, and so that's AB. And then on the large triangle, I know CE, and that corresponds with the length of BC on the small triangle. And so now I can put all those values in. The only thing I don't know is DE. So I have the length of DE over 8.2, and that's equal to 24.0 over 9.3. And so now it's just a matter of rearranging that to solve for DE. And it's really as simple as just multiplying by 8.2. 8.2 on the top and bottom, the left cancels out. And then we multiply the 24 by 8.2, divide by 9.3. The 24 times 8.2, if you wanted to do that intermediate step, you don't have to do that necessarily. But if you did, it would give you 196.8, and your denominator being 9.3 would give a DE value, a length of DE of 21.2 meters. Then you want to do just a quick mental check to say that's a little bit shorter than 24, just like 8.2 is a little shorter than 9.3 on the small triangle. So now what we're going to do is we're going to move on to 90-degree triangles. These next two examples have to do with 90-degree triangles. Now, normally with 90-degree triangles, we have the Pythagorean theorem. And so the Pythagorean theorem is something that you've been working at for years with, and that's a squared plus b squared equals c squared, where that c value is the hypotenuse. Now, that's all well and good if you're trying to find a third side if you know two of the sides, but what if we know angles that we're trying to solve instead? If we're trying to solve angles instead, we now use SOH CAH TOA. And so the SO stands for sine is opposite over hypotenuse. The cosine stands for adjacent over hypotenuse. And the TOA stands for tan equals opposite over adjacent. Now it's worth noting that sine, cos, and tan all operate on an angle. They're not multiplied by an angle. They need that angle to operate on. So let's just go over what those opposite, adjacent, and hypotenuse are. If the angle is drawn like so, the adjacent is the angle beside it that's not the hypotenuse, and the opposite is the opposite side of the triangle. Now, I've labeled the angle here up at the top. The opposite side is the side opposite, and the adjacent is right beside. So it's important to keep that in mind. The opposite can change, and can the adjacent, depending on where the angle is that you're referring to. So with that in mind, let's look at this first example. Determine the value of x in the diagram below. Now you can see that the opposite side is x and the hypotenuse is 20.2. And so that would mean we need to use the sine law. So sine says opposite over hypotenuse. We sub in the angle of 42. The opposite side is x and the hypotenuse is 20.2. And then we just multiply both sides by 20.2 in order to get x by itself. It cancels off on the right side. And we get x equals 20.2 times sine of 42 degrees. Make sure your calculator is in degrees, and you'll get the answer of 13.5 meters. Sometimes your calculator could be in gradians or radians, and so it's very important that you make sure it's in degrees when you calculate these. So there you go, 13.5, it's shorter than the hypotenuse, that makes sense. On the triangle below that, you can see that the opposite side to the angle is 14 and the adjacent is 11. So that requires us using the tan ratio. And so tan is opposite over adjacent. And so we go tan of the angle, we don't know the angle, is 14 over 11. In order to get the angle by itself, what we have to do is we have to do an inverse tangent. And so in order to do that, we go tan inverse by putting that little -1. And what this is done in your calculator usually is if you do shift and the tan button. It's usually just a color above the tan button in your calculator. And so we do tan inverse of 14 over 11. We can't just divide by tan because it's operating on the theta. So this undoes the theta operation. And when we put that in our calculator, we get 51.8 degrees. And that should make sense because if the angle is bigger than 45, the opposite should be longer than the adjacent side. Now we're going to look at the sine and cosine law and when you can use each of these situations. So this only applies if you do not have a 90-degree triangle. If you have a 90-degree triangle, by all means, go back and use SOH CAH TOA. Don't waste your time using these. If you don't have a 90-degree triangle, here's the sine law. Sine A over A equals sine B over B equals sine C over C. You'd use that version of the sine law if you were trying to solve an angle because it's in the numerator. But if you were trying to solve a side length, you'd actually use the reciprocal of that. A over sine A equals B over sine B equals C over sine C. And the thing to remember is you're only ever going to use a pair of these at a time. So A and B, B and C, or A and C. It all depends what you're trying to solve in a given triangle. And so what we want to note here is that the bottom version is the version that you are going to use if you're trying to solve a side length, if you don't know a side length. And the top version, on the other hand, is the version you're going to use if you don't know an angle. So it's just, like we said, it's just the reciprocal of the other. So it's nothing big that's changed. It's just you flipping everything in the fractions. Now we move on to the cosine law. The cosine law says this. It says that c squared is equal to a squared plus b squared, which is very similar to the Pythagorean theorem, but there's more to it now because it's not a 90-degree triangle. So it's minus 2ab cosine of angle C. Now we can rearrange that equation if we were trying to solve for the angle C. It would become c squared. We subtract a squared and b squared from both sides. So we get c squared minus a squared minus b squared. And then we divide by the negative 2ab in front of the cos C. That would cancel out. And then we just take cos inverse of everything that's left on the left side. And so you get cos inverse of c squared minus a squared minus b squared over negative 2ab. There's a video I'm going to mention at the end that goes into more detail about how to do that if I went over that too quickly for you. It's also in the description below. So in the first version, it's when we don't know one of the side lengths. In the last version, it's when we don't know an angle. And so we're going to look at when we use each of these beyond that now with a couple of just situations that we're going to see below. So on the left, we're going to look at the first situation that we're going to use the sine law for. And that is a situation where we have pairs of known things, at least one pair, an angle and the corresponding side that we know. So if we know side angle, for example, so a situation might be like 10, 14, and 36. We have two sides that are joined to each other, and then an angle that is not in between those two sides. The other way you could think about it is that that one side pairs up with the angle that's across from it. And then what that would allow us to do is it would allow us to solve the angle that's across from the side that's 14. The other situation would be angle side. And so that would be a situation where we know two angles and the side opposite one of those angles again. And so you can see there, we've got 36, then 40, and then it's not the side that's between those two angles, it's another side that we're using. And so that allows us to solve the side that's opposite the 40-degree angle. So side angle, angle side, those are the two situations when you can use the sine law to solve. What about the cosine law? The cosine law can be used when a triangle has side, angle, side. I like to say a triangle is giving you sass. When it's doing that, we cosine it. And so that was a situation where the angle is actually between two known sides. And so I want you to notice here, there's no pair of side with the opposite angle, or no angle with the opposite side that pairs up and we have those two values for. We never have a pair like we did in the sine law. So the cosine law is used in that. In the first case of the cosine law, that's what we'd use in the side angle side. And the other situation you run into with the cosine law is if you're given all three sides. And in that case, you'd use the rearranged form of the cosine law for the angle. And that's what we're going to do a little bit in some examples to follow. So this example says solve for angle A in the triangle below. And so in this case, we have a pair of side with an angle, or in other words, you could look at this as being side angle. And so we know we're going to use the sine law. And so the sine law, if we're trying to solve for an angle A, means that we want to write sine A on the top. So we start with sine A over A equals sine of capital C over C. And so what we're going to do now is sub in everything we know. We know that little a is 14, the length of A, and we know that the angle C is 36 and little length C is 10. So we want sine A by itself, so we multiply both sides by 14. Now I'm multiplying the right side by 14 in the front just so we don't complicate it and think that the sine is operating on the 14 as well. It's not. So don't ever make the sine operate on the 14. Don't go 36 times 14 or anything like that. So the 14 divided by 14 cancels out, and we're left with sine A is equal to 14 times sine 36 degrees over 10. So remember, because the sine operates on angle A, in order to get sine to the other side, we have to do sine inverse. And so that's going to be shift sine on our calculator. And so the way you would type that in most of the time on your calculator is you type in the 14 times sine 36 degrees, divide it by 10, get that answer. It's 0.822899 repeated. Goes on from there. And then you can take sine inverse of that by getting shift sine, and you get an angle of about 55.4 degrees. The last example we're going to look at is solving for length b of a triangle below. And so this triangle is giving a side with the angle and then another side. So side angle side. That means we're going to use the cosine law. The other thing you can do is you can look at pairs of angles with known sides that are opposite. There's no pairs. So we know we have to use the cosine law. Now notice here, because it's side b we don't know, we're writing the cosine law with b squared equals a squared plus c squared, the two sides we do know, minus ac times cosine of b. That little b, the length of b, has to correspond with the angle at the very end. And all the other letters are for the other two sides. So what we get is b squared equals 14 squared plus 10 squared minus 2 times 14 times 10 times cosine, and we sub in that angle b, 104 degrees. Now in order to get the length b by itself, we have to take the square root. So we take the square root of all this. 14 squared is 196. 10 squared is 100. And then 2 times 14 times 10 gives us negative 280. And then the cosine of 104. And here's where a lot of people make a mistake. They take the 280 and the cosine of 104, and they don't multiply that first. You have to remember your orders of operation. You must multiply that before subtracting it from the other numbers. So if you've done that properly, what you end up getting is 363.73813, and it goes on and on from there. After taking the square root of that, you get 19.1 meters. And you'll notice that because that's opposite the 104 degree angle, that should make sense that it is the longest side on the triangle. So always ask yourself that when you finish the question. Does that make sense according to the diagram that I have labeled earlier on?
Thanks so much for watching. I hope that was helpful, and if it was, please consider subscribing. You can see more on some important topics with these 3 videos shown here.